We have virtual network components. These can be created to consist solely of virtual machines on the physical servers. Most networks combine physical and virtual elements. So in many business networks, you'll see there will be some machines on the network that are real physical machines. You know, it's a computer you would go typically sit down at and you can touch and play with the components. And then there are going to be virtual machines on the network as well. A lot of times these will be servers, can also be desktops, and that's a different technology, kind of. It's VDI, virtual desktop environments. But they'll all work together. They'll all think that they're on the same, depending on how you set the network card. So we'll talk about those three different methods here in just a second. Let's see. The virtualization programs, such as the VMware that showed you, VirtualBox, which is free, or Virtual PC from Microsoft, which is not very good. They assigned VMs software and hardware characteristics. They are very easy to use and include step-by-step wizards, and there are tons and tons of videos and free and paid training for them. They use operating system images, so these are your ISO files. So if you go to your DreamSpark account and you download Windows 7 or Windows Server, it'll download as a .iso, and you can create a new operating system directly from that ISO file without having to burn it to a disk. And I have another video on my YouTube channel that will show you how to do that to create a new virtual machine. Network connections requires a virtual adapter, so that's all set up when you install your virtualization software. So this is kind of what we were just looking at here. So this is specifying the VM, and again, I'll show you how easy that is. So if I go in here to any of my VMs, I can edit the virtual machine settings, and it's just as simple as, oh, that one's paused, so that one's not turned off. Let me try this one over here. I can go to my memory, and I can either drag it up and down, or I can do it here, or I can type it in, however I want to do it. Same thing with changing the processors. Again, you're limited by what you have on your machine, but you can change all of these settings. I can tell you which virtualization engine to use. Again, you're limited by the physical hardware that's in here. So if I didn't have the processor I had, I wouldn't have these options to virtualize with Intel VTX, because it's not built into some of the lower end processors. If I start to run out of disk space, I can go in here, do some advanced configurations, and I can add more disk space. I can either add it as a new separate disk where it'll look like it's just a completely new hard drive that's plugged in, or I can reformat this and repartition it. CD drive, I can tell it to go to an ISO file, so that's what I was talking about just a second ago, or I can tell it to use the physical drive. So when I put something in the CD drive on my host machine, it will see it in the virtual machine if the virtual machine's running. Floppy drive, I'll actually remove this because I don't keep a floppy drive on here. Network adapter, we're going to talk about these in just a moment. The bridged versus NAT versus host only. Let me see if I have all of these in bridge. Maybe I have some of these in NAT and some in bridge, and we'll talk about the difference here. USB, so that just connects all my USBs. I found that sometimes putting it in USB 3, even though my host device does have USB 3, sometimes the virtual machines, they have a hard time recognizing some of the older devices. If I have it set to USB 3.0, the host computer will be fine, but the virtual machine will have trouble. So that's one of those few times where the virtual machine has additional complexity and it doesn't operate just like a physical machine. Sound card, usually it connects right away. Sometimes with some Linux distributions, you'll have to go find some drivers, but the software is getting better and better and easier to use. Printer, so I just found the printer that I have installed on my host operating system, and same thing here. So that's all that. Let me see if I'm trying. I just want to check and see. Yeah. So I have this one in NAT, and then I have this one in bridged, and I'll talk about the difference there. And this one's in NAT, bridged, NAT. Yeah. So I have most of them in NAT, which is our network address translation, and then it had at least 2 that were bridged. So let's get back to the slides and talk about the differences there. But it's really easy to make those changes. This is where you can set the amount of bandwidth that you allow each of the virtual machines to utilize. Virtual switches and bridges. Virtual bridge or switch is created when the VM's NIC is first selected. It connects the VM with a host, and it resides in RAM on the host device. A virtual switch is logically defined device, operates at the data link layer of our OSI model, and it passes frames between nodes. The virtual bridge connects the virtual network cards with the network. So we'll have some diagrams here in just a second to kind of explain that. So we have, these are our different VMs. This is a virtual switch that's operated within our software, so within our VMware. And this is our hypervisor. These are 2 different physical NICs, and this goes out to our physical network. Here it connects to a router, and they exchange traffic through the router. So these are on 2 separate networks. So we have host A, host B. So they're going the same thing. They're going to their virtual switch, out through their physical network card to a router, and then the reverse path, and then the data can get to our virtual machines. Must identify networking mode and VNIC we'll use. So when you're setting it up, when you're setting up the virtual machine, it'll ask you which of these modes you want to use, the bridged, network address, or host only. Bridged, a NIC is allowed to access the physical network using host machine's network card. It obtains its own IP address, default gateway, and netmask from the DHCP server on the physical LAN. So instead of getting the IP address from the host device, from my computer, so don't think about this as the host. Think of the host as this blue box. It doesn't ask this host for an IP address. What it does is it acts just like a computer that is connected to the same network. So this is your buddy just walking into your house, turning on his computer, connecting to your wireless router, and needing an IP address. So it goes through the same process. So it goes through and it looks out there, sends out a broadcast, and it says, hey, I need an IP address. And so whatever is handing out IP addresses, if you have a DHCP server, or more likely you have your wireless router handling DHCP, it says, okay, sure, here it is, and it sends the IP information back to each device. So we see this is our device 132, and this is 133, and the IP address for the physical machine is our 131. So you see these are all in the same subnet, same network, so they would be able to easily network together, so we could transfer files back and forth. And this is in bridge mode. So that's why I had those 2 in bridge mode. I wanted to share some drives between my host computer or some different computers on my network, and so I put those in bridged mode so they can be able to communicate back and forth. And right, just like I showed you in the software there, you just select bridged. The other one is NAT. It's our network address translation. It obtains the IP from the host. So this would be from my laptop. It wouldn't be from the wireless router or DHCP server. It would be on my laptop. So my laptop would act like the DHCP server. It would never send a broadcast or a request to the real DHCP server for my network. So the contrast is, instead of going out to, we saw before there was a DHCP server out here that it contacted and asked for an IP address. Instead, in NAT, what it does is using a private address, and it just goes to the software, to the VMware software, and it says, I need an IP address, and so the host device gives it a new IP address. So these guys cannot communicate networking to the other physical devices on the network. So kind of want to contrast those. So NAT looks like this, and then bridged looks like this. Okay. And this is what NAT would look like in the settings. And then host only, similar to NAT, but the traffic is only going from VM to VM. It's not going anywhere. It's not going outside. So this would just be if you wanted to set up a network just between your virtual machines. That would be when you would use the host only. So you notice I didn't have any of mine in host only because I haven't had a need that I wanted to keep it that way, where I just needed two different virtual machines to communicate with each other. And I think I'll cut this video off here because it's been pretty long, but just kind of a quick recap. We talked about the different types of network configuration. So we have host only, where they just communicate with each other. We have NAT, where it communicates with the host device to get its IP address. Then we have the bridged mode, where it acts like it's a new physical computer on the same network, and it communicates with whatever is serving your DHCP. Talked about all that, and talked about switches and bridges, what a different network is, the mostly advantages of virtualization and a few disadvantages, caveated with they're not purely disadvantages here. Talked about how the hypervisor works and what virtualization is, and that's it. So thank you for watching this video. I hope this has been useful for you, and have a great day.